Okay, from worksheet 2, number 4, we're trying to figure out the scale reading here. So let's draw on all the forces. First I'm going to redraw this. Maybe not. Let's see. Okay, so this is the beam. There's going to be a force, the X, from the 1 kilogram mass down this way. There is going to be a force, the X, from the scale this way. There's going to be a force, the X, from the pivot point this way. And there's going to be a weight force acting from the 2 kilogram mass here. So this is where the pivot point is going to be. So look at this. This is the weight of the 2 kilogram. This is the weight of the 1 kilogram. This is the support force from the scale. And this will be the support force from the pivot point or the fulcrum. Okay, so I know that the support force from the fulcrum plus the support force from the scale has got to be equal to W2 plus W1, which would be 30 newtons. But I have two unknowns, so I need to use torque now. So I know that the torque from the weight 2 plus the torque from the scale have to balance out the torque from the weight 1 kilogram weight. And so this is going to be 20 newtons times the distance away. I don't know. I guess it does tell me it's 0.1 meters equals, plus the support force from the scale times the distance away, which is 0.2 meters, equals the weight from the 1 kilogram, which is 10 newtons, times the distance away, which is 10, 20, 30, 40, 0.4 meters. And from this I can figure out what the support from the scale is. That would be 10 newtons. Or maybe it measures in masses, so the mass that the scale reads would be equal to 1 kilogram. It's interesting, I don't think it asks here, but it might be interesting to figure out what the support force from the fulcrum is going to be equal to the 30 newtons minus the support force from the scale, which is 10 newtons. So the fulcrum is providing a force of 20 newtons. It doesn't ask for it, but I still think it's kind of interesting.